everybody? Good. I see some great costumes out there. That's fun. So I'm Sarah Brownlee. I'm a professor of geology at Wayne State University, and I am here to talk to you about caves. Who knows what a cave is? Most of you. Cool. Well, so a cave is simply a cavern or a hole or cavity that's carved out of rock. It's usually underground, or it has some roof over top. So you could go inside of a cave to hide from the rain if you wanted, or from the snow. So caves, to make a cave, you have to either remove rock or you have to build rock up. You have to somehow make a roof. So you could think there's basically two ways that you could make a cave. And you can compare this to how you might make an igloo. Who's made igloos in the winter? I used to do that a lot when I was a kid. So you could build an igloo by digging a tunnel through a big pile of snow, or you could pile up bricks of snow until you have a roof over your head. And actually, you can make caves out of rocks in the same way. Most caves are actually made by removing material through a process called erosion. And there's a special kind of cave that's actually formed by a roof being built first and then stuff flowing through, and that's called a lava tube cave. And I'm going to talk to you a little bit about all of these to sort of just give you an introduction on caves. There are actually 4 different kinds of caves, and they're different based on how they form and where you find them. So the first one I'm going to mention is the sea cave. Who has a guess at where you might find a sea cave? Go ahead. What's that? By the sea, for instance? Yeah? Under the water, maybe? Yeah? At the ocean? Yeah, so sea caves are actually formed by wave action, removing material or rock. So sea caves are most common on the shores of the ocean, where you have very high power waves that are just crashing into the rocks all day long, and eventually they carve out a cave. You can also find sea caves around lakes, lake shores. The 2 things that you need to form a sea cave are you need high energy water, so you need waves, and you need rock that is strong enough to form a cave. So it wouldn't work if all you have on shore is sand, for instance. But if you have strong rocks and strong waves, you can form a sea cave. So here's an image of a sea cave. So we're inside the sea cave looking out, and you can see the water that has formed it. This is kind of a poor resolution image, but you can sometimes take boats inside of sea caves. So that's a pretty cool way to explore sea caves. Another kind of cave is called an erosional cave. Now, I've already mentioned that removal of material is called erosion. So in a way, a sea cave is also an erosional cave, but this is a special kind of erosion where we have groundwater flowing through the rocks and removing material as it flows through, and it starts to just chip away at the rock as the groundwater flows. So what you have here is we're underground. I'm trying to use a laser pointer. It doesn't work on the screen. We're underground, and this is a granitic rock. It's a very strong rock. It's not the same kind of rock that most caves are formed out of, which I'll get to in a moment. But this whole cave here, this cavern, has been formed by water just flowing through. And a cool thing that happens when water flows really fast over rocks is if you have a little pebble in the water, it starts to swirl around in an eddy, and it'll basically drill holes into the rock. So you see this circular hole right here? That's formed by one little pebble as the water flows through, and it has an eddy in that circular hole, and it just drills down. And there's a lot of those in here. So here's a picture showing how strong the water flows through this cave, and this guy is sitting in one of those little pools. That's at the bottom of that little pool is a little rock, and that little rock has carved out that hole. Other things can cause erosion besides water. Anyone have any guesses? Just shout it out. Wind. That's excellent. So wind also causes erosion, and wind can form caves. This is most common in areas where the rocks are basically sandstone. Sandstone is a rock that is made up of little grains of sand that are held together by some form of cement or geologic glue. So the wind, if it's strong enough, it can chip out one grain of sand at a time, and eventually it starts to carve out a cave. So this is just an image of some caves that have formed by wind erosion. You can also find caves in ice. These are called glacial caves. You might not be able to tell from this image, but all of this right here is glacial ice. This is a little bit different than the snow that we see in the wintertime. It's much more dense and it stays around for a long time. So this cave has actually been carved out by, down here we have water. So up a ways uphill there's some ice melting. The water has to flow downhill. As it flows, it carves out of the ice and you get a glacial cave. Here's another image of a beautiful glacial cave. So now I'm going to get to the one of the cool types of caves, definitely not the most common. It's called a lava tube cave. So, lava. Who knows what lava is? It's hot. Yes, it's hot. What else can you say about lava? Go ahead, both of you. It's liquid. It's almost like a rock. What were you going to say? It's from a volcano. Yeah, so lava tube caves are a type of cave that forms as a specific kind of lava flows. So this is basaltic lava, which is a lava that's very hot. It's almost 1200 degrees Celsius, so that's very, very hot. It flows fairly quickly in terms of lava, but it flows like a river, like a liquid. So as it flows, the top of that liquid lava actually freezes and it forms a crust over top. That crust then allows the liquid lava underneath to stay liquid and it flows great distances. So what we're looking at here is a crust, and this window is called a skylight. So we're looking through the skylight at the hot lava underneath. As this lava flows, it carves out a tunnel, and in that tunnel that's your lava cave. So here's an image showing this is hot lava flowing, and wherever it's black, it's started to freeze and it's starting to form that crust. So this is the type of cave that forms by building a roof first rather than carving out material that was already there. Just a couple more pictures of this. We're starting to see some interesting features here, and these are some things that we're going to talk about in great detail for our other caves when we get to solution caves. But these sorts of features form in lava tube caves as well. They look a little bit like icicles, don't they? That's from hot lava dripping down, and as it drips, it freezes, and we get little icicles. Just some more pictures to show that the roof of these lava tubes is strong enough to stand on, as long as you're very careful and you have boots that can handle the hot rock, because this is all very hot. And I particularly like this image because it reminds me of a jack-o'-lantern, and it's almost Halloween. So we're just looking inside one of these lava tube caves. So I actually have a video. So this is lava flowing through one of these lava tube caves. So you can see that you're getting little icicles hanging down, and this is just the liquid lava. I just like this video. It's not particularly unique to caves, but it's showing you how liquid lava flows. He's asking, how did they film that without melting the camera? So they're actually they're standing outside looking through one of those skylights into the lava tube, and their camera is just zoomed in really far. That's how they did that. They didn't go inside the cave while that lava's flowing through. That would be really dangerous. Okay, so now I'm getting to the fourth type of cave. So I've talked about three so far: sea caves, erosional caves, and lava tube caves. Now we're going to talk about really the most common type of cave, which is called a solution cave. So these caves are actually formed by dissolving the rock. So we talked about caves forming by removing material. In this case, the material is actually being dissolved away. So these caves can only form in certain kinds of rocks. These are kinds of rocks that can be dissolved in very weakly acidic water. The most common of these rocks is called limestone. It's made of calcium carbonate, and I have a piece of it up here. And what I'm going to do is actually I have a piece of limestone and I have some very weak acid, and I would invite anyone who is interested to come down. I'm going to put a drip on here and you'll see that it actually starts to fizz and bubble as this limestone is being dissolved. Okay. See it bubbling?
Oh yeah, now I see it.
Yeah. So it's bubbling because the acid is actually dissolving the calcium carbonate in that rock. Thank you. We can do this again after as well. So.
All right, guys, go right. Go right back, guys.
So that was a very weak acid that I was pouring on that calcium carbonate. It turns out that rainwater can be very weakly acidic. Not enough to hurt you, it's not bad for you, but over long periods of time, that weak acid actually dissolves rocks, and it works really well on calcium carbonate. It also works well on salt, which is a rock formed by evaporation. And I'll show you some pictures of salt caves later. But basically, this is a diagram of a cave system. So all of these caverns have actually formed by the rock being dissolved away by weakly acidic groundwater. These are, once again, these are the most common type of cave. There are really cool formations inside of caves. Who has heard of a stalactite? I see some people have. So this picture right here, what does this look like to people? Icicles. It looks just like icicles. And actually they form in a somewhat similar way to icicles. Icicles form when cold water drips down and it freezes a little bit, leaves behind a couple crystals of ice, the rest of the water drips away. How these form is groundwater that has been flowing through the ground for a while, so it's been dissolving rock as it flows and drips. So it has minerals dissolved in it. As that groundwater drips into the cave, it leaves behind little crystals of the minerals that have been dissolved. And so over time you grow these icicle-shaped things called stalactites. A couple other images of it. So each of these is formed as over time, long periods of time. So these take a lot longer to grow than icicles on your house. These take hundreds, even thousands of years to grow. So if you ever go into a cave, you need to be careful not to damage any of these guys because they took a really long time to grow. And they're very beautiful, and they can actually, these are growing straight down, but sometimes they grow at weird, funky angles. Anyone have a guess at why that might happen? I see a hand over there. What's your guess?
Because, like, if you touch them, they might get crooked and they might, like, break.
They might break, maybe they're breaking, and then...
Maybe from the weight.
From the wind?
Wind.
Wind! Yeah! So, caves, even though they're underground, they do have air flowing through them. And if it's windy inside the cave and that drip of water comes down, the wind is blowing it this way, so as it leaves behind a couple crystals, that stalactite grows a little bit in that direction. And so you get these oriented or bent stalactites. So, what happens when that water, it still has minerals dissolved in it as it drips down and it lands on the ground? Well, it starts to grow another cave formation called a stalagmite. So now you can see our stalactites coming down from the top, our little icicles, and we have our stalagmites growing up from the bottom. So each time one of these guys drips, it lands on the ground, deposits more minerals, and you build up a stalagmite. Sometimes they connect, and you get a column where you've got your stalactite and your stalagmite all in one column. Here's just a couple more images of stalagmites. They don't always look the same. These ones are really smooth, but you can see that the water's landing here, dripping down the sides, and eventually depositing minerals as it flows. And these things can get really big. Formations in caves can get really huge. This right here, this red thing, that's actually a person. And I'm pretty sure that that person is even taller than me. Most people are. So these stalagmites are huge. That's a really big cave. This is another cave formation that's called a soda straw. You can just barely see that these things are actually hollow. The water drips down the inside and it leaves behind the minerals only on the edges. This is actually the very beginning of a stalactite. This is how they first start to grow. So when they're first forming, they form these little straws, and they're very, very delicate, so they break really easily. Here's a whole bunch of these soda straws. Cave formations don't always grow the way you might expect. So these are little curlicues. These are called keeluk, and they're actually formed in similar ways as the stalactites, that there's water coming in, dripping down, but one of the ideas is that there's little impurities in that water or crystals that form on one side, causing the drip to move in one direction, and it actually keeps happening and you get these weird shapes. Here's just another image of those. This is another funny looking thing. This is also the same kinds of minerals that form our stalactites and stalagmites, except here, instead of water dripping down and leaving behind stuff, your crystals are forming at the top and pushing everything else down. And you keep doing that and you end up with this pile of stuff at the bottom. So this is a fibrous stalactite, basically. This is another cave formation. What does this look like to anyone? Just bacon. It looks just like bacon, doesn't it? In fact, cavers will call this bacon. It's actually something called a drapery. The name of the formation is a drapery. So this is also made out of calcium carbonate. Water coming in, seeping through the cave, sometimes it flows along the roof of the cave. And it doesn't always take a straight path. And as it flows, it leaves behind little crystals. And over time, you get these areas where the water keeps following that same path and leaving behind. So these grow from the top down. And the reason you get the different colors is that sometimes the water that's dripping into the cave has more iron in it. Iron leaves behind this red color, and sometimes it'll have less. And that can depend on a lot of things. Sometimes it even depends on the climate, how warm it is, how rainy it is. And so you can learn sometimes about the past climate by looking at the banding in these. Here's just another image showing that often with the iron banding, it really does look like bacon. Another food-oriented cave formation is called popcorn. This is also calcium carbonate, and it forms these little blobs. And they actually, this picture doesn't look too much like popcorn, but if you look here, that's what these are. So you can see why cavers decided to call this formation popcorn. So I mentioned that these are solution caves formed by dissolving the rock away, and they're common in limestone. They're also common in evaporite rocks such as salt. And in fact, Michigan has some of the few salt caves. Those blue areas are showing where there are salt caves in Michigan. That's some of the few salt caves in the US that are underground and not exposed at the surface. Salt caves look very similar to our limestone caves. We have formations like stalactites and stalagmites. We get interesting banding from salt deposits having different impurities in it. And so here we have some columns. And sometimes you get real just salt crystals growing. This is the same as the salt on your table. It's halite or calcium chloride. So you could actually break this off and put it on your popcorn or something if you wanted. Okay. So who knows what animals live in caves? Go ahead. Bats. Yeah? A bear? Maybe a bear is going to live in a cave. Yeah? A lion? Sure. If I were a lion, I would want to stay out of the rain and live in a cave. Yeah? Worms? Sure. A spider? Yeah, spiders. Mice? A woolly mammoth? Maybe back a long time ago, certainly. Actually, a lot of animals can live in caves. Bats are the most well known. Here's a picture of a bat. One thing that happens to animals that live in caves, they need to be able to get around in the dark. So bats they have this special ability called echolocation that allows them to navigate through that cave in pure darkness. Bats can see, interesting enough. They're not blind, they can actually see, but they have developed this ability to use little pieces of sound to find their way around their cave. You also find lots of bugs in caves. This is a cave cricket, and even this cricket has some special adaptations for living in a cave where there's not as much other food for it to eat. It has extra long feelers on it to help it find its food. You can find salamanders in caves. This is a type of salamander that you might find in a cave, but you might also find at the surface. It's not only adapted for caves, but there are some animals and critters that are. So this is a crab, but this is a kind of crab that you would only find in a cave. Notice that it's all white. It has no pigment. So it has evolved to live in pure darkness. It doesn't have any eyes. They don't even have the organs for eyes. They don't have any pigment to them. And here's an example of, I believe this creature is called a proteus. And it's kind of like that salamander, but now once again, it has no pigment or coloration, and it has no eyes. So there would be eyes here. There are no eyes on this creature. So he has evolved particularly to live inside of caves. Other things you might find in caves are geologists. And this is one of our students at Wayne State on a field trip to Carlsbad Caverns. And that is the last picture that I have, but I have up here specimens, and I invite everyone to come and take a look at these. You can touch them. We've got stalactites. I have a big stalagmite here. This is some of that popcorn that you might find on the coming off the ceiling. Acid on, that's why we don't want you to touch it.
Whoa.
Whoa. Don't drop it. Here, I'm gonna bring one of these. Can I bring this one over to the woman in the wheelchair? Stalactites will be